Ladies and gentlemen, let's move on to our next session this afternoon. Her Space, Her Story, Women Scientists at the Frontier of Space Exploration. To take it from here, I'd like to call upon stage our moderator, Raj Chengappa, Group Editorial Director, Publishing India Today Group. May I also invite on stage our panelists, Dr. Annapurni Subramaniam, Director, Indian Institute of Astrophysics, Nigar Shaji, Project Director, Aditya-L1 Mission. Handing over to Mr. Chengappa.
This really is a celebration of India's achievement in space exploration, particularly our brilliant women scientists. And firstly, let's of course give Team ISRO and India as well a huge applause for Chandrayaan-3 success. They are our space heroes. And today we have the privilege of having two of India's top women scientists who are poised again to make space history, if I may say so, with the Aditya-L1 mission, which is India's first mission to explore the sun. Both of these scientists have overcome tremendous gender biases and patriarchal resistance to reach the top of their respective positions. Let's give them a very warm round of applause for that as well. Joining me on the extreme left is Nigar Shaji, a top ISRO scientist and the project director of Aditya-L1 Mission. And we have, of course, Professor Annapurni Subramaniam, director of Indian Institute of Astrophysics. Both of them are linked intimately with the Aditya project. Nigar for sending up the spacecraft right up to this tremendous distance, and Annapurni for designing the various experiments that will bring back this. Of course, you're also involved. But let's begin. You just had a review meeting, I'm told, this morning. You'll had a Zoom meeting on Aditya and the progress. Can you give us an update? Aditya was launched last month. Where is Aditya, the spacecraft, reached in terms of the distance, and what more needs to be done?
Yeah. After the successful soft landing of Chandrayaan-3, Aditya-L1, we had the launch on September 2nd. And following that, we had our orbit-rising maneuvers, and that is completed successfully. And it's on September 18th, it left the sphere of influence of the Earth. And now presently, it's at around 10 lakh kilometers.
So that's 1 million kilometers, right? The distance from here to the moon is about 400,000 kilometers, 4 lakh kilometers.
Yes.
So you've crossed well beyond the moon, and now
Now we are just orbiting around the sun. We are totally from the influence of the Earth. So because around 9.2 lakh kilometer, we'll be totally out of the influence of the Earth.
What is the speed it's traveling at when you, is it about 11 kilometers per second or higher?
That's because it varies, depends on the orbital position. So average, you can say.
So the speed that they're traveling it is that if you took a flight from Europe to, say, Berlin to New York, you'd reach there in about 5 minutes. Is that the speed you're traveling? That's just to give you an idea of that speed, right? Yeah. And you are now going to reach, when will you reach the point where you can begin your observation? Which date is that?
Yeah, we have 2 more course correction maneuvers. And by January 1st week, we'll be in a position to insert into the halo orbit around the sun at the Lagrangian point.
So the Lagrange point is where it'll be 1.5 million kilometers away?
Yes.
That's 1% the distance to the sun, right?
Yes,
the sun is like 150 million kilometers.
Yes.
But that point allows you to stay stationary and observe the sun without untrammeled observations, without the solar eclipse and lunar eclipse.
Actually, the point rotates along with the Earth. So we'll be able to view the sun on the other side. So that's a very vantage point for the sun observation.
Now let's come to you, Annapurni Subramaniam. You have, designer of one of the key experiments. Let's ask an ABC question. Why should we be studying the sun? I mean, we've had 20 missions in the past before Aditya went up, and USA and Germany and others have dominated. But firstly, why should we look at the sun? What will the sun tell us?
Yeah, so I come from the Indian Institute of Astrophysics, and we have the huge heritage of studying the sun for more than 100 years. So we have this famous Kodaikanal Solar Observatory. It was established in 1899, and we have been observing the sun from 1904 onwards.
So what makes Aditya so special?
So that's what I'm saying. So look at the sun, that's a star we live with. And we need to understand it, we need to understand its tantrums, because we do see the coronal mass ejections from sun and the magnetic field activities of the sun. So the activity is of the time scale of 11-year cycle. So you need to have multiples of 11 years to actually understand what the solar cycle means.
So it sort of flips 11 years.
That's right. So in fact, it becomes 22, right? So you need to have multiples of the to understand. So we already have more than 100 years of data, and we have been collecting it and studying the sun. Now, what else do you want to do now, right? So if you have seen total solar eclipses, people go take experiments to do total solar eclipse, right? Why do you want to do that? Because sun has got a corona. And corona is where you actually see the coronal mass ejections come and the way in which the matter flies out to the interplanetary space, including the Earth. So if you want to see the corona, you have to actually cut out the light of the solar disk. Okay. And that's when you actually get to do the experiment. Now you have to wait for a total solar eclipse to happen, okay, to do that, right? But what if you can actually make a total solar eclipse inside your instrument, and you can do it all the time?
Right.
So that is what the thing is. And why do you want to see the corona? Corona is because that is when the mass ejection starts. When the sun erupts or sun burps, then the mass ejections come. And that is what it travels towards the interplanetary space, causing space weather and the eruptions in our power grid, your communication, etc., etc.
I think that's a very important point, because we don't realize it. There's solar winds that's blowing across.
That's right.
The magnetic fields that come across. And if it blows too much, our entire telemetry and everything else will be disturbed.
That's right,
And so you're studying the behavior. One of the things you're studying is looking at the behavior of the corona and the solar wind process that is in there, right?
Yeah. And also heating of the corona. The gas in the corona is 1,000,000 degree Kelvin.
1,000,000 degrees?
Yeah, that is the same temperature as inside the sun. The surface of the sun is about few thousands, 5,000. But how did you heat up the gas just outside it to 1,000,000? So the scientific
and then it gets
world
hotter, apparently. It goes to 15,000 degrees centigrade as it moves
then
into the corona.
chromosphere and then corona. So the corona is a very thin gas, very hot gas.
Just
so
to give just to give you an idea of the temperature, steel melts at what, 1,000 degrees centigrade?
Yeah.
So you're going at 15 times, and therefore any spacecraft, if it gets too close to it, will just vanish. Am I right?
That's right, yes.
So let's come to you, Nigar. What is the, we built Chandrayaan, we had a lander, we had a rover, highly successful. We failed the first time, but second time we came back with glorious results. What's the degree of difficulty, and what is it that you specialize in when you look at Aditya? What is the area that you've, apart being project director, what is the degree of difficulty in this process of reaching the sun? Because then you have the experiments, but before that.
Yeah, actually, we are doing it for the first time. We are going to this Lagrangian point around L1. When you know Lagrangian point is it's an imaginary point where the gravitational pull of both the sun and the earth balances, and it acts as a small force. So having a spacecraft around it, it's the first time we are trying. So the spacecraft need to balance between the pull of the sun and the earth, and has to be around that. So that's a real challenge. Mission management is the real challenge in Aditya-L1. And it's you can visualize like a ball on the hilltop. So if you don't balance, either it can move towards the either side, that is towards the sun or towards the earth. So that's the first time we are. It's also a three body problem, and also it is the orbit also is a 3-dimensional orbit. So it's not a perpendicular plane or anything. That orbit will be wobbling, and it is a 3-dimensional one. So such a thing we are trying for the first time. That's the biggest challenge. And also the instruments, what they have developed, it requires a very high pointing accuracy to look at the sun. So for that we have made special sensors so that we will maintain that pointing accuracy what the instruments demands. So these are all the major two challenges. Apart from that, any spacecraft making is a big challenge. So because it involves a lot of complex engineering and science. So that way, these two are the major challenges.
Well, yeah, I mean, you've put it very well. Could be a physics lesson in some senses, but the fact is that even to get to that precision point, it's like, firing a 1 rupee coin at some great distance and trying to hit it, right? I mean, it has to be so precise. If it just moves a little this side, you lose the spacecraft.
Yes.
Am I right on this one? But let's come to the other part of this, which is women and space exploration. And we'll begin with you, Annapurni. Both of you all come from small towns, right? You come from Palakkad, that's in Kerala, and you come from Tenkasi, that is in Tamil Nadu. When you took it up, why did you take to space or astrophysics in this particular thing, was there resistance from your family? Your family were musicians. I'm told your father and mother were very good players of this. Why didn't you take to art and, why didn't you take to art and not science?
Yeah, so I grew up in Palakkad, and one of the things which I still cherish when I was a small child was looking up at the night sky. And we had the privilege of looking at the night sky and seeing the stars. I don't think any of this younger generation have this privilege. And if I have to tell them that how beautiful the sky is, they just stare at me, where can I go and see it? Right? So that's a very sad situation. But two things happened when I was in a remote place, and also too, we had power cuts. Nothing to do. You have to go out, you have to watch the sky. And that really inspired me. Halley's Comet and the constellations and so many things out there totally inspired me. At home, I breathed music because my parents are musicians and all the time music in and out.
You actually play the violin and
yeah,
chord.
I'm a Carnatic violinist as well. So we can't escape music at home. But I was very passionate about doing science. My parents were not against me doing science, but they were kind of not very happy me doing engineering though. So pure science, they didn't have a problem, but it's just all up to me because I had a plan B that was always music, but then I thought if I take music, I will not be able to continue science. But if I take science, I can continue music. So I decided to do that and then continued science.
And why astronomy? Didn't your parents have any issues with astronomy? But give a warm round of applause for that. Yes.
Yeah,
astronomy. Did your parents have any objection to astronomy? You said engineering, they were not.
Yeah, but when I took up astronomy, they said fine. But then I told them that I'm going to look at the night sky and spend time, hours together or days together, weeks together in the observatory. A few days later, my mom came and told me, how about studying the sun? You see, the sun rises up in the sky in the morning and then sets in the west in the evening. Isn't that the better way to study the stars or whatever? I didn't understand what she's aiming at because she didn't have any idea about anything. So then I realized that as a girl child, she didn't want me to go and spend time in the observatory.
At night.
At night. So the good thing would be to study the sun. The only way to overcome that was to take them there and show them. So what is the observatory like? How does things work there? Why I'm passionate about it, show them, and actually I shared my passion with them and how happy I'm doing that. That really changed the whole scenario.
Another round of applause for her. And Nigar Shaji has an equally inspiring story. You come from a real small town in Tenkasi, actually a village, Senkota, I forgot the name right. And you then wanted to take up science. Was there resistance from your parents? Was there resistance from, your friends around you, society? How did it work and how did you get in?
No, actually, my parents were very supportive. Actually, my father he did his undergraduate in maths, so he is very much interested in maths and physics. And even my brother he's a PhD in physics. So that way, we have an interest in physics. But engineering, I always like to do what many are not doing. So that way I chose engineering at that point of time. Now that lot of women are doing. So that point of time, it was not very a common one. So I like to do that.
How many women were there in your class when you were doing engineering?
Yeah, we were the total strength of 120, 100 are male and 20 are women.
Wow. So the ratio is very little. And did you face discrimination? You also come from, if I may say, ask this question, from a Muslim community. Was there any problems you had mingling, and were there any societal issues at that particular point?
I didn't face any problem, but in our community at that point of time, women were not very encouraged to do very higher education. So, but my parents were not like that, so I could do it. Okay,
let's give a warm round of applause for that as well. Let's come to the other issue, is women at the workplace, in this case, in your, scientific institutions. Do you all have a level playing field? Is there a lot of patriarchal resistance to having someone like you on top of Indian Institute of Astrophysics is one of the most prestigious institutes. Were there any difficulties you faced, and what would be the correctives you would say are required if there was?
Yeah, the Institute of Astrophysics actually has a long heritage of having women at all levels. So people in general see women taking part in decision making at levels, etc. But we never had a head of the institution as a woman.
You're the first woman director.
Woman director of that. So what basically happens is that what I have come across is that there's no direct discrimination, but there will always be an obscure thing that, okay, can she do it? Can she live up to the expectation? So if something goes wrong, they'll say, okay, maybe she can't take it, she can't do it. So that kind of a confidence level with the feel around you is not very positive or supportive. So always you have to take a double dose of confidence within you to take the next step. Can I do it? You'll always question yourself, can I do it, can I do it? Because, particularly because you yourself, you don't see too many role models around you, but also because the kind of feel around you is not very positive about it. So you have to overcome doubly.
Wow.
Yeah. So I think I always tell women that don't doubt yourself. There won't be any feel around you to support you. So don't even look for feels around you. Just you are confident about it, just go ahead and do it. So that's what I keep telling myself, because I also end up in such situations quite often.
What a wonderful message. Let's give a warm round of applause for that, for all women on this. And Nigar, I'm sure you also, when you come to, what is the, in terms of ISRO seems a more enlightened organization, as we can see a lot of scientists. But were there issues, especially when you were young and you were trying to move up, were there issues of discrimination, and how did you overcome it? What was the kind of things you did to do that, as well as balance your family life? I guess that's the other issue that you have to do.
It's actually, in ISRO, there is no glass ceiling or anything, and I never had a feeling that I'm a female, so I need to do. But naturally, women, I feel, we have, because of the stereotyping and the societal, we have, our self-assessment is comparatively less, and you have to put more than double the effort to be more assertive and to be in the place of decision making. It's the inherent and the societal pressure what you get that's only pulling you. Otherwise, as an organization, it was the environment was very conducive, and I never felt I have to. But otherwise, for climbing up the ladder, you have to put in a lot of effort. So that time, the work-life balance comes into play. So unless you have a good support system at home, because still it's not, so many places we can talk that men and we are sharing all the burden of the families, but still it's the more percentages on the women's shoulder. So set up a good supportive system so that you can spend more time in your career, and you can spend, because it's naturally you need to spend more time if you want to climb up the ladder. It's irrespective of men or women, you have to put in a lot of effort. So for that, you build what I learned is have a good supportive system to take care of the family responsibilities too. So my family was very supportive, and my mother was very supportive for me. So I could spend extra hours, because in space there is no time. So if you go in the morning, you don't know when you will be back.
Right.
So that's the type of work we do. So that is a support system which helped me to climb the ladder like this.
And how would you look at it, this work-life balance where I think both of you all have two children, son and a daughter in your case. How did you balance these two things?
It's not easy at all. My message is that, of course, I fully agree with Nigar that support system is extremely important. And it changes from person to person, so you need to figure out how you handle it. But I also go into the guilty feeling of, you spend more time at home, at work, then you feel that you're not, covered much at home. So I tell people that don't take average over a short time scale, because you cannot achieve everything every day. You cannot achieve everything every week. So take an average over a month or a couple of months. Then you will not feel into this guilty trap. So guilty trap is another problem where you get up doing, but actually you need to deliver, because you need to be conscious about all the requirements you have to play, but somehow manage to balance time. And discipline is the underlying term you have to take care, because without discipline, very difficult to handle multiple things. I
see Kali Puri there, who's our vice chairman of the India Today group, as well as group editorial director, a fine example of women leadership. Kali, you wanted a question? You had one? Mike, should I come? Mike? Yeah, take this. Come.
Sorry, my question is to Dr. Subramaniam. You said something very important about having a double dose of confidence. I think young women these days have a lot more role models to look up to, but along with societal pressure, they have a lot of social media pressure. And, this belief of imposter syndrome. So can you tell us a little bit about how do you do that double dose of confidence, like every day in the morning? How do you pep yourself up and say, I can do this and, I'm the woman for the job. I am the only woman for the job.
It is not easy at all. I mean, we go into this kind of thing, can I do it? Should I do it? Can I take this up? This quick keeps coming back to you. You have to keep talking to yourself, saying that you have done it. Do not doubt yourself. Even if something fails, going wrong, you said, no, be yourself. Just be yourself. You have the instinct in you. You have the capabilities in you. Just do it. Wonderful. Just go ahead and face it and do it. You can just be normal. Don't get overwhelmed. Don't get pressurized. So these should not be in the parameters at all. You're just doing your duty. So just go ahead and do it. Otherwise, if you start thinking about the peripherals around it, you get overwhelmed and you will not be able to even deliver, whatever, even in the scariest of scenarios, you can't deliver that. So I think Nigar would be the right person to talk about 30 seconds.
Go ahead and what is your advice?
Situations.
Your thoughts on this?
It's not just a confidence building, it won't come on its own. Okay, you have to look at the models, and it's inherent quality, what you get it and you can develop it. The confidence building is an art and you can always develop it. So I feel from my childhood, maybe the environment what I have grown in have given me a lot of confidence, and so that I continue to nurture it, and that helped me in my career too.
So there you have it, ladies and gentlemen. Let's give them a very warm round of applause to these two inspirational women of science. Louder, please.